this group, since anyone in this group can make any change they want to the machine. We just saw in the GUI that we're in this group, but I wonder who else is. Let's see who's in this group with get-local group member. And I want to check the administrators group. Okay, we can see that the administrator user and my user are in the administrators group, but no one else. Looks good to me. One last note. These local user and group PowerShell commands require that you're running PowerShell 5.1 or newer. You may have noticed that I keep saying local accounts and local users. If your organization has a lot of Windows machines, it's very common to use Active Directory to manage user accounts in a central directory service. In Linux, user management and access works just like it does in Windows. Different user types have different privileges, and they can be grouped together with various access levels. There are a few differences in how Linux does labeling, though. There are standard users, and there are also administrators in Linux. There's also a special user called the root user. Don't get this confused with the root directory or /. The root user is the first user that gets automatically created when we install a Linux OS. This user has all the privileges on the OS. They're the super user. There's technically only one super user or root account, but anyone that's granted access to use their powers can be called a super user too. Now, let's try and view the contents of a root restricted file. The file path is etc sudoers. Oh, we're getting an error. cat/etc/sudoers permission denied. The sudoers file is a protected file that can only be read by root. We can log in as root and then run this command, no problem, but it can be really dangerous to always be in root. Since root, like our local administrator account on Windows, has unrestricted access on the machine. If we make even one mistake, we could delete or modify something important, and that's not good. So instead of logging in as root, we can tell the shell that we want to run this one command as root. Sounds similar to the Windows UAC feature? That's because it is. On Linux, we can do this with the sudo command or super user do. So sudo cat etc sudoers. And now we're able to see the contents of this file. If you don't want to run sudo every time you need to run a command that requires root privileges, you can just use the su command or substitute user. This will allow you to change to a different user. If you don't specify a user, it defaults to root. Now you can see my prompt says root at cindy-nyc. Again, it's generally not a good guideline to stay logged in as root all the time. There are lots of critical services and files that can be mistakenly changed. If you need to log in as root, it's okay, but just be careful. I'm just going to go ahead and exit out of root for now and go back to my normal user. You can view who has access to run sudo by viewing the /etc/group file. This is also how you view memberships for all groups. This looks a bit different from the Windows GUI, but you can see there are some similarities to the Windows CLI. It's actually pretty simple to read this file, even if you're not a bash expert yet. Each line represents a different group. Let's look at the sudo line. There are 4 fields here separated by colons. The first field is the group name. In this case, it's sudo. The second field is the group password. We don't really need to specify a group password, so it defaults to the root password. The X here means that the password has been encrypted and stored in a separate file that we'll talk about in a later lesson. The third field is the ID of the group, or group ID. When our operating system runs a task that involves a group, it uses a group ID instead of a group name. And finally, the last field is a list of users in the group. What if we wanted to view the users on our machine? What do you think the file would be that stores that information? Unfortunately, it's not /etc/user. The file that contains user information is /etc/password. Oh wow, there's a lot more information in here, and a lot more users. Most of these accounts aren't actually humans using the computer. There are a bunch of processes that are constantly running on our computer that we need to associate with the user. so our system has lots of users with different permissions that are needed to run these processes. Let's look at this first line here, which is an actual user we can log into, root. We won't talk about all the fields since they aren't important, but the first three are relevant. The first field is the username, and the second field is the user password. The password isn't actually stored in this file. It's encrypted and stored in a different file, just like our group ID password. The third field here is the user ID or UID. Similar to group IDs, user IDs are how our system identifies a user, not by the username. Root has a UID of 0, and that's basically how you view users and groups in Linux. In this video, we're going to talk about an important part of having users on a machine, and that's working with passwords. Passwords add security to our user accounts and machines. They make it so that only Marty knows the magic secret to access her account and no one else's, not even the admin of the computer. When setting up a password, you want to make sure that you and only you know that password. Remember, if you're managing other people's accounts on a machine, you shouldn't know what their password is. Instead, you want the user to enter the password themselves. To reset a password in the GUI, let's go back to our computer management tool. Under local users and groups, we're going to right-click on a username, like this account, Sarah. Let's click on Properties. And then from here, we're just going to check this box that says, User must change password at next logon. And I'm going to apply and hit OK. Then, when the user logs into the account, they'll be forced to change their password. If they forgot their password, you have the option to set a password for them manually by right-clicking and selecting Set Password. This has some caveats though, like losing access to certain credentials. To change a local password in PowerShell, we're going to use the DOS-style net command. There's a native PowerShell command that can be used to set the password, but it's a little more complicated. It requires a bit of simple scripting to use. For now, we'll stick to the simpler, though less powerful, net command. Net does lots of different things. Changing local user passwords is just one of them. Since this is an old DOS-style command, you can also use the /?mark parameter to get help on the command from the CLI. To change a password for a user, the command is netuser, then the username and password. The best way to use this command is to use an asterisk instead of writing your password out on the command line. If you use an asterisk, net will pause and ask you to enter your password, like so. Why is this approach better? Imagine you're changing your password, and right at that moment, someone walks behind you and glances over your shoulder. Your password isn't a secret anymore. You should also know that in many environments, it's common that the commands that folks run on the machines they use are recorded in a log file that's sent to a central logging service. So it's best that passwords of any kind are not logged in this way. Do you notice a problem with the asterisk approach though? That's right. If I change passwords for someone else using this command, I would know their password, and that's not good. Instead, we're going to do what we did in the GUI and force the user to change the default password on their next logon using the /logon password change yes parameter. So I'm just going to force Victor to change his password on the next logon. So net user Victor /logon password change yes. The /logon password change yes parameter means that the next time that Victor logs into this computer, he'll have to change his password. Sorry, Victor. To change a password in Linux, all you need to do is run the passwd or password command. Let's try changing my password. When you set a password, it's securely scrambled, then stored in a special privileged file called /etc/shadow. This file can only be read by root to keep away prying eyes. Even if you did have access, you wouldn't be able to descramble passwords found in here. If you're managing a computer and you want to force a standard user to change their password, like we did in Windows, you can use the -e or expire flag with password, like this. This will immediately expire a user's password and then make them set a new password the next time they log in. Okay, now that you know how to view information about users and the hierarchy of user permissions, let's learn how to add and remove users on our machine. To add a user, we're going to go back to our computer management tool. Under Local Users and Groups, we're going to right-click and select New User. From here, it asks us to set a username, a full name, and a password. Remember that in order to use good password setting practices, we set a default password and then make the user change that password when they log in. So we're going to go ahead and set a default password and make sure the box for User must change password at next logon is checked, and then click Create. So I'm just going to make a new user account for Elizabeth and have a password, and then just make sure that's checked and hit Create. And that's how you create a local user. To remove a user, we simply right-click and select Delete. This gives us a warning message that says usernames are unique, and even if you delete the user and give them the exact same username, they won't be able to access their old resources. Once you confirm that you want to do that, just go ahead and delete it. And that's how you remove a local user account. Adding and removing local user accounts from the CLI is going to use the same net command that we use to change passwords, just with different parameters. Like before, there's a native PowerShell command, new-local user, that requires a little bit of scripting to use. If you want to use new-local user, check out the supplemental reading. Now, back to net. To add a new local user, we simply use the /add parameter. If we add the /add parameter to the same command we used before, it instructs net to create the account. We can still use the asterisk for the password to be prompted to enter a password. Let's test this out and create a new account for Andrea. So, net, user, Andrea, */add. Now, let's list the user accounts to be sure it worked. So get-local user. Sweet, there it is. Now there's a small problem which you saw in the earlier lesson on passwords. This account is for Andrea, but we know what the password is. We don't want to know what the password is because that means we can log in as Andrea. We want to make sure that Andrea changes her password to something that we don't know. So we're going to flag her account as requiring a password change using the /logon password change yes parameter. So net user Andrea /logon password change yes. Now you won't know what her password is. You can actually combine these two commands that we ran to create a new account that requires a password change at first login. Let's create an account for Caesar. So net user Caesar, add a password, /add /logon password change yes. Now when we run the get-local user, we should see both of our new accounts. Sweet, and there it is. Caesar's new account has a password that you know, and you can give it to him, but he'll have to change the password the first time he logs in. Alright, Now let's remove these accounts that we just created. I'm going to show you how to do this using net and using remove-local user. Both of these commands will do the exact same thing. So let's delete Andrea's account, net user Andrea /delete. This will delete Andrea's account. And using the remove-local user command, we can remove Caesar's account. Sweet, now it's gone. See how each of these options follows a pattern? The net user example looks just like it did to create a new user account, except instead of adding an account, we deleted the account. In the second example, instead of getting, setting, or creating a new -local user, we remove the account. As you continue to learn new CLI commands, you'll start to notice these sorts of patterns. Being able to identify these patterns will help you discover new things that you can do, and remember how to do things you haven't done in a while. To add a new user in Linux, you can use the user add command. So sudo user add Juan. This will set up basic configurations for the user and set up a home directory. You can verify that Juan was created there. You can combine this with the password command to make the user change their password on login. To remove a user, you can just use sudo user delete Juan. Yep, he's no longer on the list. Nice work!
Because most mobile devices are used by a single person, mobile operating systems handle user accounts a little differently than the other OSs we've talked about. Take a GPS unit in a vehicle, for example. You might never enter a username or sign into the GPS unit at all. There are still user accounts in the OS that run the GPS device, but you'll never have to see them or have to deal with them. On the other hand, think about a smartphone or tablet running iOS or Android. These devices will have you enter the username and password once when you're setting up the device, but then you'll probably not have to re-enter that password each time you want to use the device. The initial account that you use during setup is called the primary account. This account is used to create a user profile for you on the device. The user profile is sort of like your user account in a mobile device. It contains all of your accounts, preferences, and apps. In iOS and Android, the primary account can be used to synchronize settings and data to the cloud. When you replace a device or set up a new mobile device with a primary account that you've used before, you'll have the option to restore data and apps if any have been backed up to the cloud. But don't worry about this yet. We'll talk more about synchronization and backups in a future video. Also in iOS and Android, a user profile can be signed into additional accounts. These could be additional email accounts, social media accounts, or something else. If given permission, apps on the mobile device can use these accounts for single sign-on, or SSO. This means that instead of those apps asking you for another username and password, they will allow you to authenticate using an account that you're already signed into. Those apps don't have access to your credentials, but you can let them use those credentials. As an IT support specialist, you might help end users set up these accounts on their mobile devices, but don't ever ask someone for their password. Always have the end user enter the password themselves, and if anyone reveals their password to you, encourage them to change that password. Most mobile devices only support one user profile, and they're designed to be used by a single person. Some Android devices do support multiple user profiles. To see how that works, check out the supplemental reading. Think about when you use a larger device like a desktop, laptop, or a server that you have to enter a username and password to access. By default, most mobile operating systems don't ask you to re-enter your primary account password each time you want to use the device. This is convenient, but it also means that anyone who picks up the device will have access to all of your personal and work data. Even if there's no private data on the device may have access to confidential or privileged systems, which can be just as bad. Mobile operating systems usually have several ways to protect your data. You can set a device password, a PIN, or an unlock pattern on your device. Some smartphones use fingerprint sensors, facial recognition, or other kinds of biometric data to grant access to the device. Biometric data is something about you that's unique to you, like a fingerprint, a voice, or a face. To protect business data, some organizations use mobile device management or MDM policies to require mobile devices to be locked. Mobile device management systems are used to apply and enforce rules about how the device has to be configured and used.
an incredibly challenging situation.
File permissions are an important concept in computer security. We only want to give access to certain files and directories to those who need it. While we think about how we want users to access files and folders, we should also think about how the concept of permissions carries over to other areas of your life. Maybe you've locked down your social media posts to only people you trust, or given a copy of your house key to a relative in case of an emergency. For now, we're going to focus on one small building block, file permissions. In Windows, files and directory permissions are assigned using access control lists, or ACLs. Specifically, we're going to work with discretionary access control lists, or DACLs. Windows files and folders can also have system access control lists, or SACLs, assigned to them. SACLs are used to tell Windows that it should use an event log to make a note of every time someone accesses a file or folder. You can think of a DACL as a note about who can use a file and what they're allowed to do with it. Each file or folder will have an owner and one or more DACLs. Let's take a look at an example. In Windows Explorer, I have opened up my home directory. If we right-click on Desktop and select Properties, we can see the Properties dialog for our desktop directory. Then if we go to Security tab, we can see the Permissions window here. The top box contains a list of users and groups, and the bottom box has a list of the permissions that each user or group has been assigned. What do each of these permissions do? It changes a bit depending on whether the permission is assigned to a file or a directory. Don't worry, it'll all make sense soon. Let's do a rundown of these permissions. Read. The read permission lets you see that a file exists and allows you to read its contents. It also lets you read the files and directories in a directory. Read and execute. The read and execute permission lets you read files, and if the file isn't executable, you can run the file. Read and execute includes read, so if you select read and execute, read will automatically be selected. List folder contents. List folder contents is an alias for read and execute on a directory. Checking one will check the other. It means that you can read and execute files in that directory. Write. The write permission lets you make changes to a file. It might be surprising to you, but you can have write access to a file without having read permission to that file. The write permission also lets you create subdirectories and write to files in the directory. Modify. The modify permission is an umbrella permission that includes read, execute, and write. Full control. A user or group with full control can do anything they want to the file. It includes all of the permissions of modify and adds the ability to take ownership of a file and change its ACLs. Now, when we click on my username, we can see the permissions for Cindy, which show that I'm allowed all of these access permissions. If we want to see which ACLs are assigned to a file, we can use a utility designed to view and change ACLs called iCACLs, or Improved Change ACLs. Let's take a look at my desktop first. So iCACLs, desktop. Well, that looks useful, but what does it mean? I can see the user accounts that have access to my desktop, and I can see that my account is one of them. But what about the rest of this stuff? These letters represent each of the permissions that we talked about before. Let's take a look at the help for iCACLs. I bet that'll explain things. So iCACLs /?. All right, there's a description of what each one of these letters means. The F shows that I have full control of my desktop folder. iCACLs calls this full access, and we saw this in the GUI earlier as full control. These are the same permission. What do these other letters mean? NTFS permissions can be inherited, as we saw from the iCACLs help. OI means object inherit, and CI means container inherit. If I create new files or objects inside my desktop folder, they'll inherit this DACL. If I create new directories or containers in my desktop, they'll also inherit this DACL. As we've now learned, there are files and folders that have different permission sets on them so that unwanted eyes can't view or modify them. There are 3 different permissions you can have in Linux. Read. This allows someone to read the contents of a file or folder. Write. This allows someone to write information to a file or folder. And execute. This allows someone to execute a program. Let's take a look at this with the ls command. We'll use the long flag so we can see the permissions on the file. Okay, the first thing we see in this column is -rwx rw-r-. There are 10 bits here. The first one is the file type. In this example, dash means that the file we're looking at is just a regular file. Sometimes you might see D, which stands for a directory. The next 9 bits are our actual permissions. They're grouped in trios or sets of 3. The first trio refers to the permission of the owner of the file. The second trio refers to the permission of the group that this file belongs to. The last trio refers to the permission of all other users. The R stands for readable, W stands for writable, and X stands for executable. Like in binary, if a bit is set, then we say that it's enabled. So for our permissions, if a bit is a dash, it's disabled. If it has something other than a dash, it's enabled. Permissions in Linux are super flexible and powerful because they allow us to set specific permissions based on our role, such as an owner, in a group, or everyone else. Let's take a look at this in detail. The first set of permissions, RWX, refers to the permission of the user who owns that file. In this case, it's Cindy, who you can see in the owner field of ls-l. So it says here that the owner of the file can read, write, and execute this file. The next set of permissions are group permissions. We can see the group this file belongs to is the cool group. They have read and write permissions, but not execute permissions. And lastly, the permissions for all other users and groups only allow them to read this file. And that's Linux permissions in a nutshell. It might take some time to get used to reading permissions. Don't worry, you'll eventually get the hang of it. As always, feel free to review this lesson again if you need a refresher. Now that we can read permissions, let's take it a step further and learn how to change permissions in Windows. Let's say I want to give access to another person in my family to view a folder with family pictures on the computer. How would I do that? On my local disk C, I have a folder called Vacation Pictures that I want to share with another user on my machine, Devin. To do that, I'm going to right-click on this folder, then go to Properties, then the Security tab. Now I can see an option to edit file permissions. I'm going to click on that. From here, I can see that I can add a group or usernames to this ACL. I'm going to go ahead and click Add. From here, it asks me to enter the username of the person I want to add on this ACL. I'm going to enter Devin and then click Check Names to verify that I typed it in right. After it's been verified, I'm going to click OK. Once Devin's added to the ACL, I can click on his username, then check the Allow boxes for the permissions I want to give him. Let's give Devin Modify access so he can add pictures to this folder too. And that's it! We've kind of been glossing over this other checkbox here, Deny. You might have already guessed that Deny doesn't allow you to have a certain permission, but it's special because it generally takes precedence over the Allow permissions. Let's say Devin is in a group that has access to this folder. If we explicitly check the Deny box for Devin's username, even if the group has access to the folder, Devin won't. To modify a permission in the CLI, we're going to return to the iCackles command. In the examples I'm going to show you, we'll be running iCackles from PowerShell. The iCackles command was designed for the command prompt before PowerShell, and its parameters use special characters that confuse PowerShell. By surrounding iCackles parameters with single quotes, I'm telling PowerShell not to try and interpret the parameter as code. If you run these commands in command.exe, you'll need to remove the single quotes for them to work. So let's look at this side by side with PowerShell.exe and command.exe. In PowerShell, the command would be iCackles vacation pictures / grant with single quotes everyone OI CI R. In command prompt, the command would be iCackles with double quotes vacation pictures grant everyone OI CI R. We're going to see what this command does in just a moment. For now, let's take a look at the difference in the quotes. In the PowerShell example, we add single quotes to make PowerShell ignore the parentheses, and because there's a space in the path. In the command.exe example, we have to use double quotes for the path, and we don't need the single quotes anymore to hide the parentheses. Got it? Great. Now, let's take a look at the permissions that we just gave to Devin with iCackles. Cool. I see there's a new DACL attached to the Vacation Pictures directory for Devin that gives him modify access. We can see that any new files or folders that get created in Vacation Pictures will be inherited. Okay, so let's say we want anyone with permission to use this computer to be able to see these pictures. We don't want them to add or remove photos though. What permissions do we want to give them? That's right, we want to give them read permission to the Vacations Pictures folder. Let's use the special group Everyone to give read permissions to the directory. So iCackles see Vacation Pictures / grant everyone OI CI. Success! The Everyone group includes, well, everyone. It includes local user accounts like Cindy and Devin. Guest users. This is a special type of user that's allowed to use the computer without a password. Guest users are disabled by default. You might enable them in very specific situations. Now anyone who can use this computer can browse the photos that Devin and I have put together. Actually, maybe I didn't really want everyone to look at my vacation photos. Maybe I just want the people that have passwords on the computer to be able to see them. In that case, I want to use Authenticated Users group. That group doesn't include guest users. So first, let's add a new DACL. iCackles see Vacation Pictures grant Authenticated Users OI CI R. Success! Now let's remove the permissions for the Everyone group. iCackles see Vacation Pictures remove then Everyone. Success! Now let's use iCackles to verify that the permissions are set the way we intended. iCackles see Vacation Pictures. Sweet! We can see that authenticated users were added and Everyone is removed. In Linux, we change permissions using the chmod or change mode command. First, pick which permission set you want to change. The owner, which is denoted by a U, the group the file belongs to, which is denoted by a G, or other users, which is denoted by an O. To add or remove permissions, just use a plus or minus symbol that indicate who the permission affects. Let's take a look at some examples. So let's chmod u plus x my cool file. This command is saying that we want to change the permission of my cool file by giving executable or x access to the owner or you. You can do the same thing if you wanted to remove a permission. So chmod u minus x my cool file. Instead of a plus, we just minus. Pretty simple, right? If you wanted to add multiple permissions to a file, you could just do something like this. This is saying we want to add read and execute permissions for the owner of my cool file. And you can do the same for multiple permission sets. You do chmod ugo plus r my cool file. Now this says we want to add read permissions for our owner, the group the file belongs to, and all other users and groups. This format of using RWX and UGO to denote permissions and users in chmod is known as symbolic format. We can also change permissions numerically, which is much faster and simpler, and lets us change all permissions at once. The numerical equivalent of RWX is 4 for read or R, 2 for write or W, and 1 for execute or X. To set permissions, we add these numbers for every permission set we want to affect. Let's take a look at an example. The first number 7 is our owner's permission, the second number 5 is our group permissions, and the third number 4 is the permission for all other users. Wait a minute, where are we getting 5 and 7? Remember, you have to add the permissions together. If you add 4, 2, and 1 together, you get RWX, which equals 7. So our owner permission is able to read, write, and execute this file. Can you guess what 5 would stand for? That's right. 4 plus 1 is read and execute. So now you can see how numeric format is quicker than symbolic format. Instead of running something like this, we can run chmod 75 change mode command. First, pick which permissions. You can practice changing their permissions on a few files. until you get it down. Permissions are an essential building block to computer security, and you'll be using them throughout your work as an IT support specialist. You might have noticed that when we were looking at permissions in the GUI before, there's a checkbox in the permission list for special permissions. The permissions that we've been looking at and setting so far are called simple permissions. Simple permissions are actually sets of special or specific permissions. For example, when you set the read permission on a file, you're actually setting multiple special permissions. But it can also let you create real In Linux, we also have special permissions. What if I want a user to be able to do something that requires root privileges, but I don't want to give them these privileges? What's the use case for this? Glad you asked. There are certain commands that need to change files that are owned by root. Normally, if you need to change a file owned by root, you would have to use sudo. But we want to be able to have normal users change these files without giving them root access. Let's check out an example. Let's say I want to change my password. I would use the password command like we've learned. Pretty simple, right? Now I just enter in my new password, and my password is changed. We know that the password command secretly scrambles up our pet UID. We can enable files to be run in security. For now, Congrats! You've made it to the halfway mark in this course. You already learned how to navigate around the Windows and Linux file systems. You also learned how to manage users and groups, and the basics of permissions and access. Nice work! Next, we're going to learn about packages and the major package managers for Windows and Linux. Installing and maintaining packages is something you'll do almost every day in an IT support role, so you should be familiar with how this works on the Windows and Linux OSs. Let's get to it! Have you ever wondered how we get software like the apps in the App Store or packages on the internet to install on our devices? Wonder no more. Developers and organizations that make the software we use generally package them up nicely for us. In most cases, all we need to do is click Install, and the package gets installed for us. Packaging comes in all sorts of shapes and sizes. It's just like how you'd package a gift for someone. You could put it in a box or a bag, but the contents are what really matter. Developers have different ways to package software using software compiling tools, but the end result is a package. In the next few videos, we'll discuss some of the most common package types you'll see when you work in IT support. In Windows, software is usually packaged as a .exe or executable file. Executable files contain instructions for a computer to execute when they're run, like copy this file from here to here, install this program, or more generically, perform this operation. The concept of an executable file isn't unique to Windows, but Windows has its own special implementation of them in the form of EXEs. They're created according to Microsoft's Portable Executable, or PE format. Although we won't get into the details of the PE format, it's good to know that EXE files don't just contain instructions for the computer to perform. They also include things like text or computer code, images that the program might use, and potentially something called an MSI file. A Microsoft Install Package, or MSI, is used to guide a program called the Windows Installer in the installation, maintenance, and removal of programs on the Windows operating system. Besides using the GUI setup wizard to guide the user in installing the program, the Windows Installer also uses the MSI file to create instructions on how to remove the program if the user wants to uninstall it. Windows executable files are usually used as starting points to bootstrap the Windows installer. In this case, they might just contain an MSI file and some instructions to start up the Windows installer and read it. Alternatively, executables can be used as standalone custom installers with no MSI file or usage of the Windows installer. If they're packaged this way, the exe file will need to contain all the instructions the operating system needs to install the program. So when would you use an MSI file and the Windows installer? And when would you use an executable with a custom installer packaged in something like setup.exe? Great questions. If you want precise granular control over the actions Windows takes when installing your software, you might go the custom installer route. This can be tricky though, especially when managing things like code dependencies, which we'll talk about later. On the flip side, using the Windows installer, guided by an MSI file, takes care of a lot of the bookkeeping and setup for you. But it has some pretty strict rules about how the software gets installed. As of Windows 8, Microsoft has introduced a platform to distribute programs called the Windows Store. The Windows Store is an application repository, or warehouse, where you can download and install universal Windows platform apps. Those are the applications that can run on any compatible Windows devices like desktop PCs or tablets. These programs use a format called APPX to package their contents and act like a unit of distribution. We won't go into detail about APPX packages, but it's good to know they're out there, giving you another option for packaging software. We learned how to install exe packages in an earlier course. To install an exe from the GUI, all we need to do is double-click on the executable, then go through the installation process provided, either by the executable itself or the Windows installer. That's pretty straightforward, but what about installing software from the command line? And why would you need to do this in the first place? Hold on to your desktops because you're about to find out. Installing executables from the command line can be handy in lots of IT support scenarios, including automatic installations. You might want to write a script or use the configuration management tool to install some software automatically without needing a human to click buttons in an installation wizard. So how can you install an executable from the command line? The answer? It depends. Pretty unsatisfying, I know. Running exe files from the command line is pretty simple. You open up a command prompt or PowerShell, change into the directory where the executable is, and type in its name. You can also just type the absolute path of the exe from wherever you are in the file system, like this: c/users /cindy /desktop below.exe. Running from an installer from the command line is similar, but will potentially have more options for installation. Depending on the installer, you might have flags for things like a silent installation, where nothing shows up on the screen and the package is installed quietly. Or you might get an argument to have the computer reboot automatically after the package is installed. A given installer might have these kinds of options for installing from the command line, but they vary from vendor to vendor. The options available for a Microsoft package might differ from the options for a Mozilla package. Pro tip: try using the /? Parameter when running a package from the command line to see what kinds of subcommands the package might support. If the package doesn't have any help-related options, your best bet is to check out the vendor's documentation for what kinds of installations their software or packages support. In Linux, there are lots of different distributions, and each might have different package types. For example, in the Linux distribution or distro Red Hat, the packages that are used are .rpm or Red Hat Package Manager packages. We won't cover how to work with RPM packages, but just be aware that package types can change when you're working with different Linux distributions. In this course, we'll be working with Debian packages, which Ubuntu uses. A Debian package is packaged as a .deb file for Debian. You'll have to work with standalone Debian packages, especially when developers package and release their software on different websites. To install a Debian package, you'll need to use the dpackage or Debian package command. There's a standalone package here for the open source text editor Atom. Let's go ahead and install it using dpackage. We have to use the I flag for the install. And that's it. Now it's installed on this computer. How about if we wanted to remove a